Welcome to this FP2 video on higher derivatives. So this is the start of a series of videos on the Maclaurin and Taylor series for FP2. And before we get into first looking at the Maclaurin series, we need to just make sure everyone's comfortable with higher derivatives. So that is just simply differentiating several times. So, if I have y equals f of x and I differentiate y, I get dy by dx, or f dash of x. If I differentiate the second time, I get d2y by dx squared, or f double dash of x, and differentiating the third time, I get d3y by dx cubed, or f123 of x, and so on, all the way down to the nth differentiated derivative, I should say, like so. Okay, so that is what we're in a nutshell going to just do a short video on. And then afterwards, the next video, we'll start looking at the Maclaurin series. So going to look at just a couple of examples. So here is the first one. Find the value of d3y by dx cubed when x equals 1/4. So I've got y equals ln 2 minus x. Now, if I differentiate this, I get 1 over 2 minus x times, and now the derivative of this. So if I differentiate 2 minus x, I get minus 1. So it's going to be times minus 1. So this is minus 1 over 2 minus x. And then go in a second time. So if I think of this here as minus 2 minus x to the minus 1, if I'm differentiating, I'm going to bring this minus 1 down, and this is going to become minus 2. So minus 1 comes down, so it's going to be positive. This is going to become minus 2, and then I multiply by the inside differentiated, so it's minus 1. So minus 1 over 2 minus x cubed. Oh, sorry, not cubed. Squared. Don't know where I was going then. Now, for the next one, we're looking at d3y by dx cubed. And again, if I differentiate it, the minus 2 comes down. So I get a positive 2 minus x to the minus 3, multiplied by the inside of the bracket, differentiated. So we get minus 2 over 2 minus x cubed. Now we want the value when x equals 1/4. So d3y by dx cubed equals minus 2 over 2 minus 1/4 cubed. And this is minus 128 over 343. And that's it, just very, very simple. To do the Maclaurin series, it is going to be about differentiating quite a bit and substituting values in, but I'll talk more about that in the next video. For now, let's look at our second example. So, given that y equals e to the power 2 plus 5x, find an expression in terms of y for dny by dx to the power n. So, first thing I need to do here is differentiate a few times and look for a pattern. So when I differentiate, this will stay the same, and then I'm going to multiply by this power differentiated, which is going to be 5. That gives me 5. Differentiate a second time, so it's going to be 5e2 plus 5x times by 5, so it'll be 25. And cubed, I think I see the pattern. So it's going to be 125e to the 2 plus 5x. Okay, so here is the pattern. So this one is 5e to the 2 plus 5x. It's 5 to the power 1. This is 5 to the power 2, e to the 2 plus 5x. This is 5 to the power 3, e 2 plus 5x. Therefore, dny by dx to the power n will be 5 to the power n e to the 2 plus 5x. And there we have part A done. Oh no, it does say in terms of y. Okay, y is this, e to the power 2 plus 5x. So this will actually be 5 to the power n multiplied by y. Now we're done with part A. Okay, part B, hence evaluate d to the power 6y over dx to the power 6 when x equals ln 1 over 25. So let's write this down first. So to the power 6 is going to be 5 to the power 6 e to the 2 plus 5x. Now when x is ln 1 over 25, we get 5 to the power 6 e to the 2 plus 5 ln 1 over 25. So this is 5 to the power 6 e squared times e to the ln 1 over 25 to the power 5, which is 5 to the power 6 e squared 1 over 25 to the power 5. Now let's do a little bit of simplifying. We could just put this all into your calculator at this point, but I like to, simplify it. So we've got 5 to the power 6, 1 over 5 to the power 10 e squared. So it's 1 over 5 to the power 4 e squared. 1 over 5 to the power 4 is 1 over 6 to 5 e squared. Of course, I could have just done this up here in my calculator. Okay, and I'll leave the e squared here, but if it did say give the three answer to 3 significant figures or 2 decimal places, then obviously I would have. Okay, so that's kind of all there is to it for this video. Just 2 examples, and I've got a couple of questions for you. If you found this video useful so far, hit that like button, subscribe if you're yet to subscribe, and if you're willing and able to help me out financially, hit that join button. Otherwise, let's look at a couple of straightforward questions, and the answers will be at the end as normal. So here they are, 3 questions. 1, a bit of differentiating, 2, similar to the example that I just did, and then 3, just something slightly different. So pause the video now, bash out these 3 questions and then double check your answers in a moment. Okay, hopefully you're ready for the answers. Here they come. Question 1. So for this one we have to find the first 3 derivatives and then the nth one. So let y equals e to the 4x, then dy. Well, actually, let me rewrite this as f of x. Keep it in the terminology of the question. So this will become 4e to the 4x. Differentiate the second time will be 16e to the 4x. Differentiate the third time would be 16 times 4, 64 e to the 4x. That means the nth one is 4 to the power n e to the 4x. Okay, right, let's have a look at b. So this time let f of x equal 1 minus x to the power n. Now, if I'm differentiating the first time, I get n 1 minus x to the n minus 1 multiplied by minus 1. So it's minus n 1 minus x to the n minus 1. Now, f of 2 will be, so we've got minus n times n minus 1, 1 minus x, n minus 2 times by minus 1, so it's n minus 1, 1 minus x to the n minus 2. And then the third one is n minus 1, n minus 2, 1 minus x to the n minus 3 times by minus 1. So this is going to become a minus. Now for the f to the nth power, so this one, so we've got n minus n minus n times n minus 1, n times n minus 1, n minus 2, then it'll be n times n minus 1 times n minus 2 times n minus 3, and so on. Now that part of it can be written as n factorial. Okay, now it's alternating sign, so negative sign, positive sign, negative sign. So this is going to be times by minus 1, I think to the power n. Let's check it. So when we're looking at n being 1, so that works because when n is positive, then this will be positive. So if n is 2, this will be plus 1, and when n is 3, this will be minus 1. When n is 4, it will be plus 1. So that works out there. And then what happens to the 1 minus x goes to the power, well, it's n minus n, isn't it? The final one, which will be 0. Anything to the power 0 is 1. So we got minus 1 to the power n of n factorial. Okay, C. So let f of x equals x e to the 2x. So differentiate the first time, we get Right, so differentiate this times this, which will be e to the 2x plus this times this differentiated, so that'll be 2x e to the 2x. Now differentiate the second time, 2e to the 2x plus, now differentiating this one, so let's differentiate this first, so 2e to the 2x plus 2x times this e to the 2x differentiated will become 4x e to the 2x. So that is 4e to the 2x plus 4x e to the 2x. So I think we're starting to find a pattern. Let's check with the third one. Okay, at the moment the pattern looks like, well, this has gone from 1 and 2, 4 and 4. Let's see what the next one is. So differentiating this, we get 8e to the 2x plus 4e to the 2x plus 8x e to the 2x. So that is 12e to the 2x plus 8x e to the 2x. So we've gone from 1 to 4 to 12. That's a bit of an awkward pattern, isn't it? Yeah, so I can't spot it straight away, so I've just made a bit of room. And let's look at factorising. So let's factorise out 2x, and we get 1 plus x in this case, isn't it? No, 1 plus 2x. And if I factorise out, oh sorry, not this one, the simplified one, I can factorise out 4e to the 2x, and that gives me 1 plus x in here. And let's factorise out here, we can factorise out 4e to the 2x, and we get 3 plus 2x here. I think I've got it. Right, if I factorise out 2 here, there we are. Factorise out 2 here. So this pattern has gone, the 2x stays the same. This has gone 1 for the first derivative, 2 for the second derivative, 3 for the third derivative. And this has gone 1, 2, 4. So this could be 2 to the power 0 e to the 2x, and then this 1 will be my n, and because this is then 2 to the power 1 e to the 2x, 1 plus 2x, sorry, 2 plus 2x, and this is 2 to the power 2 e to the 2x, 3 plus 2x. I could just double check it with a fourth one, so let's just double check it with the fourth one to be sure. Okay, but I think I've done enough. So this is going to become 24e to, oh, let's predict it first of all. So predicting it will be 2 cubed e to the 2x, 4 plus 2x. That's my prediction. Okay, so differentiating it, we've got 24e to the 2x plus 8e to the 2x plus 16x e to the 2x, which is 32e to the 2x plus 16e to the 2x. So I'll take e to the 2x out, and if I want to keep this is 16x. If I want to keep that as 2x, then it's going to become taking 8 out. So if I take 8 out there, it's going to be 4, and take 8 out. So this will give me 32, and this will give me 16, and this is this. So yeah, that is my plan. So it's 2 to the power n e to the 2x. No, it's 2 to the power n minus 1, isn't it? E to the 2x, and then n plus 2x in my bracket. So that one was a lot more challenging, but we got there in the end. Right, let's look at part D. So f of x equals ln 1 plus x. F dash of x is 1 over 1 plus x, or I'll leave it as 1 plus x to the minus 1, just because it'll be easier when I'm differentiating. So this has become minus 1 plus x to the minus 2. Now the third one is 2. 1 plus x to the minus 3. Let's check the fourth one. I know I don't need to, but to help me find the nth one, I'll times this one then by minus 3 times 2. So a bit of a pattern. Now, if I just do this in red, this one here was minus 1 times 1 plus x to the minus 2. This one was minus 1 times minus 2 times 1 plus x to the minus 3. This one is minus 1, minus 2, minus 3 times 1 plus x to the minus 4. So there is a pattern. So to find our f of n, so we're going to f to the power n, the nth derivative, let's just say that. So n is 4, n is 3, n is 2, n is 1. So this is 1 less than n factorial. N minus 1 factorial. And that will give me the 3 times 2 times 1 and the 2 times 1 and the 1, but it won't give me the minus. Now, this one will give me a minus 1 for an even power. This one gives me a positive 1 for an odd power. So it's going to be times by n minus 1 to the power n. No, it's going to be, minus 1 to the power n minus 1. Okay, so when n is 2 minus 1, this is power 1, gives me an odd, it gives me a minus. When it's 3 minus 2 is 3 minus 1 is 2, so minus 1 squared is plus 1, so it's positive, and this is going to be positive. So that now makes sense. And then it's times 1 plus x to the minus n. So we've got minus 1 to the n minus 1 times n minus 1 factorial times 1 plus x to the power minus n. Okay, and there we have it. All four of these have done. Hopefully you were able to do that. Some little challenging ones in there. And if you weren't, hopefully you were able to follow how I did it. Now let's look at number 2. This one's going to be, I think, a lot easier. Okay, so it's like the example. So we got y equals e to the 3 plus 2x, and we're going to differentiate. So we get 2e to the 3 plus 2x. Differentiate a second time, and I get 4e to the 3 plus 2x. I differentiate a third time, and I get 8e to the 3 plus 2x. So these are like 2 to the power now, e to the 3 plus 2x. Okay, so the nth one is going to be 2 to the power n e minus 2x, so e to the power 3 minus 2x, which is 2 to the power n times y. So that's part A done. So now let's do part B. So the sixth derivative is going to be 2 to the power 6 e to the 3 plus 2x, but x is ln a quarter. So it's going to be 2 to the power 6 e cubed e to the power ln a quarter squared. So it's 2 to the power 6 e cubed, and this is going to be 1 over, well, I can make it 1 over 2 squared, which would be 1 over 2 to the power 4. So this is going to be now 2 squared e cubed, or 4e cubed. And of course you could do that all in your calculator. Now let's look at the final question. So we've got f of x. We've got to find f of 0, f dash of 0, f double dash of 0. So let's differentiate each of these first. So I'll write f of x 2e to the x squared. F dash of x, gonna multiply by this differentiated, so it's going to be 2x, so it's going to become 4x e to the x squared, and times by 2x again, it become 8x squared e to the x squared, and then the third one times by 2x again, 16x cubed e to the x squared. Now, when I substitute 0 in for x, I get 2e to the power 0, so this is going to be 2. This is going to become 0 because the x outside. In fact, the rest of these now are going to be 0. And there we have it. Question 3 complete. So, nice short video for you. Next video, like I said, we'll be getting into the Maclaurin series. So stay tuned for that, coming in a couple of days. Otherwise, all that's left to do is to remind you to like the video if you found it useful. Subscribe if you're yet to subscribe. and join if you're willing and able to help me out financially. You only have to join for a month or longer, it's up to you, but every little bit will help. See you next time.